Okay, question number 6 is an integration by substitution question. So the first thing I always do is, on the right hand side of my page, work out what I'm going to swap dx for. So to do that, I'm going to differentiate this. Don't need to rearrange it before I differentiate it, I'm just going to differentiate it as it is. So when I differentiate this right hand side, I'm going to get nothing plus 1 over x. And if I times by x and times by dx, I now know that dx is the same as x du. So what that means I can do is when I come over here, I can change first of all ln x. Well, ln x is going to be u take 1, just from here. So I've got a u take 1 on the top. I've got an x here, which I'm going to just leave alone for a second. And I've got a 1 plus ln x in a bracket that's being squared. So that's now just going to be u squared. And I've got a dx, but we now know dx can be written as x du. And conveniently, these x's cancel. So that will leave us with u take away 1 over u squared du, which we need to integrate. We can't quite integrate it yet. It's not a straightforward ln, because if we differentiate the bottom, we don't get the top. We've got a u take 1 on the top here. But what we can do is separate these two fractions out. We can change this to u over u squared minus 1 over u squared. And u over u squared is the same as 1 over u. And this, if I write it in negative index form, is u to the minus 2. Now we can integrate. This is easy to integrate. This is just ln u. And this, think core 2, don't think too difficult. Add 1 to the power, divide by the new power. And L plus c as well, because it's an indefinite interval question. So if we tidy this up, to start with, we're going to get ln u plus, these minuses are going to cancel, plus 1 over u plus c. And then our last job is to swap u back for 1 plus ln x. One plus ln x is always positive, because ln x is always positive, so I don't need my mod signs. And don't worry that we're logging a log, that's fine. But that's our final answer.